Hey, welcome to Lesson 6. Today we're going to be learning about imaginary and complex numbers. What? Complex? What does that mean? We're going to learn about the number I. What? I is a letter, not a number. Let's do some review. We're looking at page 87. We're going to start with number 1. We're going to do number 2. It says determine the zeros of each function. So remember to do that. Let's switch it up to red here. We're going to get 0 is going to be equal to x squared minus 25. Now there's two ways you can solve this. You can factor it or you can use square roots. I'm just going to use square roots because that seems to be the easiest way here. So we will add 25 to each side. We get 25 equals x squared. And then when we take square roots, remember when we square root a square, we have to use plus or minus. Let's move that up. So we're going to get plus or minus 5. So we get two roots for number 1, x equals 5 and x equals negative 5. All right, let's look at number 2. Number 2 is a little bit different. We have it in vertex form. So I'm still going to use square roots though, because that seems to be the easiest way to do it. So let's add 9 to each side. We're going to, oh, that's a 9. All right, there we go. So 9 equals x minus 1 squared, right? Because they cancel out. And then we're going to take the square root to get rid of that square over here. We cannot forget the plus or minus. So we get plus or minus 3 is going to be equal to just an x minus 1. We can add 1 to each side. And hopefully you're okay with this notation with a plus minus. We're going to get 1 plus or minus 3 should equal x. And we know that 1 plus 3 is 4. And 1 minus 3 is negative 2. So we found the roots or the zeros, right? The zeros are when the function is equal to 0. Now, question, what happens when the function does not cross the x-axis? That's what we're talking about today. We have 3 different functions right here. We want to start off on page 88 listing all the key characteristics you know about each function. I'll start with the blue one and then you can do the red one and whatever color this one is. So we want to talk about the key characteristics, the things that describe this graph. So we're talking about like the zeros. I know for the blue one there's 1 0, right here at 5. And we talked about this before. When it touches just one time, it's a repeated root or a double 0, we would say. But it does have 1 0 at 5. It's a double 0. X-intercepts are the same as the roots, right? So the x-intercept here would be 5. The y-intercept, I can't tell from the graph, but if I plug a 0 in here, x equals 0, that's the y-axis, right? So if I plug a 0 into here, then I'll get f of x equals 25. So I know the y-intercept is at 0, 25. The axis of symmetry is the line that goes through the vertex. So there's a line right here that goes right through 5. So I would say that is x equals 5. And then once I have that x equals 5, I can plug it into the equation. So we would plug in a 5 here. We would get 5 squared is 25 minus 10 times 5, which is 50. And then plus 25. All that works out to 0. So the vertex would be 5, 0, which appears to work out right here. I'm going to write all of these characteristics down for the blue graph right here. All right, there's 1, 0, the x-intercept, the y-intercept, the axis of symmetry, and the vertex. All right, that was a lot, but I want you to do the red and the greenish graph over here. Do them by yourself. So pause the video and do those 2 other parts to number 1. Go. And hopefully you had no problem doing that. Here's what I got for each one of these where I really want you to focus. Make sure you pause the video if you need to and write some of these down. But notice how this one does not touch the x-axis. So we're inclined to say it has no roots, right? There are no zeros here. Well, it kind of does have zeros. It just doesn't have any real zeros. Like Mr. Sullivan's friends. There are no real zeros. They're imaginary. Oh, that is sad. Compare these 3 functions. What do they have in common and what is different about them? Again, pause the video if you need some help writing this down. But in common, they each have a y-intercept and an axis of symmetry and a vertex, but they have a different number of zeros. We have 1 0, 2 zeros, and 0 zeros. All right, page 89. Let's look at this function. X squared plus 1. If you were to plot the graph of x squared plus 1, you would get this wonderful quadratic parabola right here. And notice it does not cross the x-axis. So let's see what happens when we try to work it out algebraically to find the zeros. We have Elena and Mark analyze the methods for determining the zeros of the function. If you notice what Elena did right here, she said x squared plus 1 equals 0. That's how we start, right? When we find the zeros, we set this equal to 0. So we put the function equal to 0. Elena did -1, -1. Got it. Took a square root. Did plus or minus square root of -1. Now, a long time ago, you learned about square roots. And having square roots of negatives, that's bad news, right? All right, let's look at Mark, and we'll come back to that. What did Mark do? Mark did what? -1, -1, x squared equals -1. And he just put x equals plus or minus 1. He took a square root of that -1 and just said it equals 1. Well, who's right here? Who's wrong? Well, it tells you who's wrong. Mark is wrong. You can't take square root of a negative. Y'all learned about that a long time ago. There's a couple math rules we have. You can't take square roots of negatives. Can't divide by 0. But Mark identified the square root of 1 rather than the square root of -1, and the graph does not cross the x-axis, so the function cannot have zeros. Look, they don't have any zeros there. There's no zeros, so Mark is definitely incorrect. Now, Elena, does her solution fall within the real number system? Now, this is it might be the first time you've heard this. The real number system means the number system that does not contain any imaginary numbers. Whoa. There are no numbers that you can multiply by itself to give you a -1. I want you to think about that. Here's the problem right here with Elena's. When we take x squared and it equals a negative, what number can you square, which means times itself, and it gives you a negative? Okay, remember, any positive squared is going to be positive, and any negative number squared will be negative. No, it won't. It'll be positive as well. I'm going to say that again because I just screwed it up. Any negative number, when you square it, it's a negative times a negative. That'll give you a positive. So there's no real, we say, there's no real solution to this equation. It's not real. It is imaginary. So to calculate the square of any real number, there must be a way to calculate the square root of a negative number. So really what happened were mathematicians were sitting around and saying, we can't take square roots of negative. It doesn't exist. And then they said, ha, I will find a way to do it. I'm just going to define it as the number I. So the number I stands for imaginary, is a number such that I squared is -1. Or in other words, the square root of -1. Let's work this out. Since I squared is -1, what does I equal? So if whatever this number is, we'll do I squared equals -1. When I take a square root of each side, I'm going to get I do put a little tail on it when I'm usually I put a little tail so we know it's not a 1. But I equals the square root of -1. So that's what mathematicians did. They said, hey, we can't take square roots of negatives, so why don't we just do this? When we're stuck with a negative number, like, for example, the square root of -25, there's a negative in there. What they decided to do was to break this thing up into a -1 and a positive 25. We can figure this part out, and we'll just call this I. So this will work out to 5 with an I. That's what they decided to do. Let's look at the number 4 here. Recall the function x squared equals x squared plus 1. Recall the function p of x equals x squared plus 1. Write the zeros of the function in terms of I. So the way we need to do that, we're going to set it equal to 0. So 0 equals x squared plus 1. We're going to subtract from each side. So we're going to get -1 equals x squared. The next step, as you know, is to take square roots. Okay, so we're going to get x equals plus or minus, right? Because we can't forget to take that plus or minus. The rules still affect. And the square root of -1 is I. So the roots for this function, we would say the roots are x equals I and x equals -I. Or you can say plus or minus I. That works okay. Functions and equations that have solutions requiring I, we call them imaginary zeros. All right, imaginary. Or we say they're imaginary roots. How can you tell from the graph whether it has real solutions or imaginary? So let's go back to that picture. How did we know this was going to have imaginary roots? Well, if you notice, it never touched the x-axis, right? So if it doesn't intersect the x-axis, then we know it will have imaginary roots or imaginary zeros. What do you think you can determine? Do you think you can determine the imaginary solutions by looking at the graph? So here were our solutions here, x equals I and x equals -I. Can we look at the graph and figure that out? Well, here's the problem. This graph deals with real numbers, not imaginary. So these numbers are not on that graph. We would need a special graph. All right, it's called a complex graph. So whenever you hear about complex numbers deal with i's and real numbers together. We're going to show you an example of that coming up. Okay, so now let's turn to page 92. I'll wait for you. Turn the page. And we're going to go to number 3 here where it says we're going to simplify and rewrite some of these. If you notice the worked example, I already kind of showed you that earlier. But I want you to write down the perfect squares, a list of perfect squares. If you remember, perfect squares are the numbers you get when you multiply integers by themselves. So this is 1 times 1. This is 2 times 2. This is 3 times 3, 4 times 4. And the reason why I want these numbers is that I'm going to simplify square roots. And when I do that, these are the numbers that I can take a square root of. For example, I can take the square root of 49, and it'll work out to a whole integer, and I'm happy, right? So that's how we simplify square roots. But let's show you how this works when we have negative numbers. We take the square root of negative 4. I'm just going to rewrite that as the square root of negative 1 times the square root of 4. Because negative 4 is really 4 times negative 1. So that negative 1, the square root of negative 1, I'm just going to call that an I. And as I said, I put a little tail on it. And the square root of 4 is 2. So I get I times 2. But I always want to write my coefficients first. I don't want to write them second. So the answer to 3a would be 2i. All right, now let's look at b. It's a little bit more complicated. I'm going to use my number line. And I'm going to say, what perfect square is a factor of 12? Or in other words, what multiplies to 12 from this line of numbers? I want to use the biggest one that I can find. 12 will break down into negative 1 times 4 times 3, right? I don't want to use 2 or 6 because neither of those are on this perfect square number line here that I've built. So the square root of negative 1, that's still going to be an I. The square root of 4, that's a 2. And the square root of 3, that doesn't simplify. So the way I'll write this is 2i with a radical 3. All right, that looks pretty good. Now we're getting a little more complicated. C is a complex number because it has a real part and an imaginary part. This will be imaginary because you're taking the square root of a negative. So we're going to keep the real numbers with the real numbers. It's called keeping it real. And then the 50, I'm going to go up here to my perfect squares. What's the largest number that will multiply to 50? 25 will, of course. So 50 I'm going to rewrite as negative 1 times 25. I'm going to write that one first, times 2. Now, that 5 is chilling, keeping it real. The negative 1 becomes an I. The 25, square root of 25, is a 5. So it's I times 5 times radical 2. But as I said, we always write the coefficient first. That way we don't mistake it for I to the 5th power. Sometimes our sloppy handwriting can do that, and that's the reason why we always want our coefficients first. So we're going to write 5 plus 5i radical 2. All right, we're doing pretty good. Part D, this one's getting even more complicated. Well, first I'm dividing by 2. Did you know we could just use the distributive property with this divided by 2? It's really times a half, right? So we're going to do 6 divided by 2. I'm going to split this up into 2 parts. It's 6 divided by 2 minus the square root of negative 8 divided by 2. So I can do 6 divided by 2 real easy. That's 3. And this becomes minus. So what multiplies to 8? I'll look at my perfect squares. Of course, we know that's a 4. So I bring out the negative. I bring out the 4. It leaves a 2. And then underneath I have a 2. Okay, so this becomes in the top what? 3 minus. We have an I. The square root of 4 is 2. So this will be 2i with a radical 2. And it's all over 2. That's a lot of 2's. But look, these are both real. Can I cancel these? No. One is inside a square root. One is a whole number integer here. But these, we can cancel those just like regular fractions. Final answer here, 3 minus I radical 2. And that is how we simplify complex numbers. Easy peasy. So then the next question becomes, how do we add them together and subtract operations or even multiply? So we're on page 97 now. This works just like as if the I were an X, except when we get an I squared, we're going to actually do something else. I'll show you that in a second. So 1a here on page 97, we're going to distribute that negative sign to each one of these and write it out. Just like we would do this if the I was a variable like X, right? We would just write it all out. Don't forget, a negative times a negative is positive. And then you can combine the terms that are the same. So we like to put the real numbers first, 3 minus 1. I'm going to put these two together first, and that's going to equal 2. And then I will put the 2i with the positive 6i, and that's just going to be 8i. And we're done with that. Boom, that was part A. Easy enough. Let's look at part B. Part B has no parentheses, so I can put the i's and the real numbers together. So let's do real numbers. Positive 3, a negative 6, and a negative 1. That's the same as 3 minus 7. That's negative 4. And now I'll put the i's together. So 4i and a positive 1i, that's 5i. As I said, these are easy. Now we're going to multiply. This is where a little trick comes in. When we multiply the 5i, it has to go to both, right? Distributive property. So we're going to get 15i. Okay, that's from the first multiplication. The second multiplication, we get a negative, or we subtract 10i squared, right? Now, we have to remember, I squared equals negative 1. What? How does that happen? That's way back here. We talked about it. Remember? I squared, where was it? I squared equals negative 1. That's what the number I is. I squared equals negative 1. That was page 90. So now I'm at 97. I squared is just a negative 1. So we're just going to replace any I squareds with negative 1. So this becomes 15i minus 10 times negative 1. This is going to turn into negative 1. But now we have a minus 10 times negative 1. That is just 15i plus 10. That works out to a positive 10, right? And you remember, of course, I said before, we always want to put the whole number first. So we're going to write this as 10 plus 15i. That was weird how I did that. But that's how you do C. Now, part D, double distribute. Here we go. This is going to be a hot mess. So we go 5 times 2 is 10. 5 times negative 3i would be negative 15i. Then we want to do the inside part here, right? So 3i times 2, that would be a positive 6i. And then 3i times negative 3i would be a negative 9. Don't forget the I squared. Now, we said before, any I squareds will turn into a negative 1. So let's do that right underneath. I'm just going to put a negative 1 there. And these i's we can put together. So we have a negative 15 plus 6. That'll give us a negative 9i. And we have that 10 that's chilling out front. So we have 10 minus 9i. And then this will end up being plus 9, right? Because it's minus 9 and a minus 1. You multiply, you get plus 9. So this 10 and this positive 9 will give us 19 minus 9i. And that's how you do part D. I was really careful not to say do D. Okay, this part, I want you to do this by yourself. It's number 2 on page 97. Pause the video, and it says determine each product. You're going to multiply all of these out and simplify them, and then unpause the video, and I'll show you if you're right. Pause the video. Okay, let's see if we could do this. Number 2. Now, I went through, I double distributed. The only tricky part is getting this. When you subtract an I squared, you're subtracting a negative 1, so you have to add it together, and you get 5. The fraction one, not too difficult, right? So I get a quarter, and then minus and plus, they cancel, and then minus and negative 1 again. We're adding 1 to it. Same thing for C, same thing for D. Go ahead and put a cup up if you don't understand this. Someone took my extra 0 away right there, but we get 10 for D. Let's see, what do I want to say? Oh, notice all of this. The i's all went away for all of these because they are a difference of perfect squares. So it equals the first number squared minus the last number squared. That's what happens in all of these. You were supposed to kind of pick that up. So there you go. Let's go to page 100. Consider the function x minus 2 quantity squared plus 1. How can you use the structure of the function to determine whether the zeros are real or imaginary? And I would say if you look at this function, the vertex is at 2, 1. That's above, let me use my pen here. I was using my mouse. But that's above the x-axis, right? So if I were to sketch this thing, here's a little sketch. 2, 1 is like up here. But a, the value of a here is positive, so I know it goes up. So I can make a conjecture that does not touch the x-axis. Therefore, the roots must be imaginary, right? It has no x-intercepts. What is the solution? Well, to get the solution, we're going to have to work it out. And for that, we're going to have to do some algebra. So let's subtract 1 from each side. We're going to get x minus 2 squared, that's a minus in there, is going to equal negative 1. I take a square root. Remember, when we take a square root of a squared, We can't forget the plus and minus, which would come over here. So this is going to be plus or minus. What's the square root of negative 1? You just get an I. Okay? So then we can add 2 to each side. Now you can kind of get the reason why we were doing this before. When we add to both sides, we put the real number first, plus or minus the imaginary number. Remember, this is really just two answers. It's 2 plus I and 2 minus I. We get two different zeros here. 2 minus I. There, I did it. Ooh, almost messed that one up. But that's the solution here when we solve it. Easy enough, right? We're just going to have to include the i's, and then we leave it at that part. Consider this function. What is the most efficient method for determining the zeros? Explain your reasoning. Well, this doesn't factor. I don't know. You can try to factor it, but it doesn't. So we're going to have to use the quadratic formula. That's the most efficient method to solve it. So I'm going to write that formula down. If you forgot, it's right here. We'll always give you the quadratic formula. And then it says determine the discriminant of the function. I'm going to put that in green. The discriminant is this part that's under the square root. Okay, this is called the discriminant. And remember, it's the b squared minus 4ac part. And so we're going to figure that part out. I've already worked with some of you and showed you how to do it in the calculator. Make sure you use your parentheses. But if you work out that discriminant and you get a negative, guess what happens? Then the function has imaginary roots. So if b squared minus 4ac is negative, which in this case you get a negative 4 when you work it out. Go ahead and work it out. Make sure you get that. Then you know the solutions will involve a number I because it's negative, and we'll have imaginary solutions. All right, what is the solution to this one? Well, we're going to have to work it out. Uh-oh. Wow, that bell rang just like that, didn't it? All right, so what are the solutions to this equation? We're going to use the quadratic equation here, the quadratic formula. So I'm just going to write out a equals 1, b equals negative 2, and c equals 2. And we're going to plug them into our formula. I'll do that over here off to the side. And I highly suggest you use parentheses when you're subbing any number in at any time. This is what we get after we plug the numbers in. So we're going to get x equals 2 plus or minus. And under this discriminant here, under the square root, we're going to get 4 minus 8. So that's going to give us a negative 4. So at this point, we can tell that we're going to have imaginary roots. So x equals 2 plus or minus the square root of negative 4, right, all over 2. And so we did a problem like this earlier. We're going to split it up into 2 over 2. Let me make some room down here. We're going to have 2 over 2 plus or minus. We're going to take that divided by 2 and spread it up into two different pieces right here. We're going to get negative 4 over 2. So 2 over 2 is 1 plus or minus. And then remember, we're going to break this up. It is the square root of negative 1 times the square root of 4. That's all going to be over 2. This is all going to equal what? Oh, I'm going to keep going down. This is a hot mess. 1 plus or minus 2i over 2. Now at this point, see how we have a whole number and it's real. 2i, you divide by 2, they're going to cancel. So the final answer here, this should be x equals, and x equals, and x equals, and we're going to get an x is going to equal 1 plus or minus, this is just an I. And that is our final solution here. 1 plus or minus I. That's going to be the solution. It's 1 plus I and 1 minus I. That's what we get for our answer right here as we had before. Make sure you work all that out. How can you check your solutions? Well, I have that down already. We need to move some of this down. But if you were to plug, let's move that down there. If you were to plug in 1 plus I and 1 minus I into the equation, it should solve it, which means it works out to 0. I'm never going to ask you to do that, so don't worry about that. But that's how you could check it. So I want you to try it all by yourself right now. Pause the video and do number 8A on page 102. All by yourself, use the quadratic formula. Go. Okay, so lastly here, I'm going to write down the solution. Go ahead and double check yourself. You should get negative 4 plus or minus the square root of 2i. And that's how you do it. All right, good luck to you. That's a long lesson, but it's all about our imaginary numbers here. So this is Mr. Kelly. Remember, it's nice to be important. It's more important to be nice. See you.